Welcome back everyone. In the previous lesson, I introduced you to the basics of object-oriented programming and why it's useful. In this lesson, we move a step forward and learn how to actually work with object-oriented programming in Python. We learn about classes, objects, and how to create them. Before we start coding, let's understand what a class is. Think of a class as a blueprint or template, just like I said in our previous lesson. Just like an architect designs a blueprint for a house, in programming, we design blueprints for objects, and these blueprints are called classes. For example, if we want to create a blueprint for a car, we can define a class called car. Once the blueprint is ready, we can then use it to create as many cars as we want. Let's start with a basic example. To create a class, you use the class keyword, followed by the name of the class you want to create. And by convention, whenever you want to create a class, the name of your class you always start with capital letter. So we use Pascal case for naming classes in Python, right? So for now, let's use the pass keyword, which means we are not doing anything for now. If you don't use the pass keyword, Python is going to give you error. So we use the pass keyword to tell Python that we are not doing anything for now. So here we've created the class named car. Right now it doesn't do anything because we use the pass statement, but soon we add attribute and methods to it. So what is an object? Once we have a class, which is the blueprint, we can create objects from that class. An object is an instance of a class. Think of a class like the blueprint for a car, and an object like an actual car built from that blueprint. Here's how we can create an object from a class. So since we've defined our class of car, so to create an object from a class, you write the name of the object you want to create from that class. So we call it my car. Then you call the class just as if you are calling a function. In this case now, my car is an object or instance of the car class. This is the object and this is the class. So my car is an instance of the car class. We can create as many objects as we want from the same class. Let's make our class more interesting by giving it some attributes. Attributes are the data or properties that an object can have. For example, a car can have attributes like brand, color, and year. In Python, we add attributes to a class using a special method called the init method. This method runs automatically whenever we create a new object from the class. In this our car class, if you want to add attributes to this class, we use the init method to add this attribute. So init method is like a function, and in defining your function, you use the def keyword. So we have the init keyword followed by parentheses, and then you have your colon. Inside of the parentheses, you first have a self keyword, and then followed by the parameters, which are the attributes that you want to add to your class. So in our car class, let's say we want to add brand, we want to add color, and we want to add year. So to assign the attribute of brand to our car class or to the objects that will be created from this class, we use self dot the name of the attribute. For now, we want to use brand, so we say is equal to brand, which is the parameter we are passing to the init function. We call this init function constructor function. So another attribute we want to pass is color, so we have self.color, which is the color parameter we are passing to the init function, and then the year. In this example, we've defined a class car with three attributes. We have the brand, the color, and year. The init method sets these attributes when we create an object. So now, in this example that we've created an object of my car from the car class, we can give these objects field values for its attributes. So for the brand, self is a keyword, it's a Python keyword, so you don't have to bother about this. So we need to bother about these parameters, and we're going to give them some real values. So for the brand, we can say this is Toyota or Honda or whatever brand you like. For the color, we can use white, and for the year we can use 2023. Now we can print this attribute of my car. So we can print my car dot brand, which is Toyota. That is what we pass as the brand. We can also print the color, which is white, and then we can print the year, which is 2023, as we pass it. If we run this now, we are going to have these 3 attributes printed into our console. So here is what happened. We created an object called my car and set its brand to Toyota, the color to white, and the year to 2023. We then printed these attributes using my car.brand, my car.color, my car.year. Once an object is created, we can access its attributes using dot notation, as you can see here. So this is what we call dot notation. As soon as an object is created and that object has some attributes defined in the class, we can access these attributes using dot notation. So to access brand now from my car object, we use my car.brand, that is the name of the object followed by dots and then the name of the attribute you want to access. So to access the color, we use my car.color. To access the year, we use my car.year. Okay, what if you want to give some attributes default values? You can do that in the init method by setting a default value in the parameter list. For example, let's say we want to add an additional attribute. Let's call it battery life. That is the lifespan of the battery that came with the car. Let's assume it's brand new. So to set default value, we can use parameters in the init method. And to do that, in front of the parameter that you want to set default value for, you use the equal sign. That is our assignment operator equal to, then the value you want to pass to it. Let's say we want to give our battery life a default value of 2 years. So you can give that possibly number, you can give it a string, dependent on your preference. So inside of the init method, then you say self.battery life is equal to battery life, which is the parameter we pass into the init function. Now, when you create a car object, you can either provide the battery life or you can leave it out. If you leave it out, it will default to the value you provide as the default attribute. Okay, we can comment this out. Let's print our battery life now. You know, when we created my car object, we did not provide any defaults, we did not provide any value as the battery life. So let's print the battery life now and see what we have in our console. If we run this now, you see that we have 2 as the value. So whenever you created an object which has a default value in its parameters, so if you do not give it a value for that default parameter, it's going to default to the value that you provided. But if you give it a custom value, then it's going to use the value that you provided. So let's say we want to give the battery life a custom value of, let's say, 5 years. So if we run this again now, it's going to partition the default value and it's going to use the custom value that you provided. So as you have seen, attributes define what an object has. But what about what an object can do? That's where methods come in. Methods are functions that belong to a class and define the actions an object can perform. Let's add a method to our car class so that a car can display its details. To add the method to a class, we define it just like a function, but it must always include the self parameter as the first argument. This allows the method to access the object attribute and other methods. So in our car class now, we can add a method that displays the information of our car. So to add the method, we use a def keyword just as if you are defining a function. So we can call this method, let's call it display info. Okay, so that's the name of our method. And whenever you are defining a method, it must have the self parameter as the first argument. So this self parameter, it allows the method to access the object attributes and other methods. Now we have a colon. So from the display info method, we can print, let's have f string. So we can say car brand. Okay. So we use curly braces to access the car brand. So we use self.brand. The self keyword, it allows the method to access the attributes from the objects that will be created from the class. Okay, so we can say the color, we have curly braces, then we have self.color, right? And we can say the year is self.year. Okay, the battery life, so we have self.battery life. Now we've added a display info method to the class. When we create a car object from this class, we can call this method to print out the details of the car. Okay, so we've created a my car here. We can as well access this method from this my car, and then it's going to display the details of my car. So let's come in now. We can comment this out, and then we can access display info. So let's say print, and then we can have my car dot display info. So we invoke the method. Method is modeled as a function, as functions. So let's run this now and see what we have. So we can see now that the display info method returns this into our console. So we have car brand to be Toyota, the color to be white, year to be 2023, battery life to be 5 years. At this point, you might be wondering what's the difference between a method and a function. Here's the main difference. A function is a block of code that does something and it can exist on its own, while a method is a function that is tied to a class. It works with objects of that class. You can think of it this way. All methods are functions, but not all functions are methods. In object-oriented programming, we use methods because they allow our objects to perform certain actions and interact with their own data. So you might have noticed that every method in the class, including the init method, has a parameter called self. So you can see the self parameter here, you can see it here. Self refers to the current object that is created from the class. It helps Python to know that the attributes belong to the object being created at that moment. Without self, Python wouldn't know which object we are talking about. It's like saying this is my current car and these are its attributes. So we can break it down using this simple example. We can comment all of this out. So we have the car class, can comment this out too, and then comment this out too. Let's close our terminal for now. So let's say we have a class of dog. So we define the init function, the init method. So we have self is important, it comes as the first parameter of any method to be defined in a class. Okay. So inside of the self method, inside of the init method, we have self.name to be equal to name. So self.name here refers to the name of the object that will be created from this class. Okay, we can have another method called speak. We have we have def and speak. So we have the self, which is content parameter for any method. So inside of the speak method, we can print to the console. So we have f-string for interpolation, self.name says woof. Okay, so from the dog class now we can create an object. Let's call the object my dog. So we have dog and then the name of my dog. So I can call it body. Now if I access the speak method for my dog, you can print, or I don't need to print because speak is already printing. So I can access the method my dog.speak. So what are we going to see? Let's run that in our console. You see we have body says woof. In this case, self.name refers to the name of the current object, which is my dog. My dog is the current object, and then the name that was provided was body. So self.name refers to the name of the current object that was created from the dog class. Python knows that self.name is body because my dog is the object we are working with. So what if you want to change the values of an object attribute after you've created the object? This is just an easy thing to do. You can modify an object attribute just like any other variable. Here is how to modify an attribute. Let's say we can comment this back. So we have our car class. Okay, so we created an object here. Now, in this example, we have Toyota as the brand of my car. We can change the brand of my car. So we have my car dot brand to be equal to, so we can change it from Toyota to Honda. So if we print my car brand now, let's uncomment this and run it again. Okay, we see that the brand of my car is now Honda. Okay, for us to have a better view, we can comment this. And then let's clear our console. Okay, so let's run this again. Okay, before modifying the brand of my car, let's print the brand. So we have my car dot brand. So let's print this now and see what we have. Okay, so initially during the initialization of my car object, we have the brand to be Toyota, but after modification, the brand changed to Honda. In this lesson, we've covered the basics of working with object-oriented programming in Python. We learned what classes and objects are. We saw how to add attributes and methods to a class. We learned how to create objects and work with them using self. Don't forget to like and subscribe to stay updated with the rest of the series. See you in the next lesson.